friends, welcome back. Last session we have seen how the deadlock is detected. Now let us see how to recover the deadlock. So one way to recover the deadlock is to terminate the process. So terminating a process will break the loop. Now the issue is which process to be terminated in that loop. So one option, abort all the deadlocked processes. If n number of processes are in a loop and they are under deadlock, then all n processes are to be aborted and all the resources allotted to them will be released and so on. That is one option. Second option, just don't know how that cycle is formed and where the cycle is and all those, but we know that some processes are under deadlock, so select one process, abort it. After aborting that process, the resources reserved by that process get automatically released, and if that can break the cycle, then these released resources will be used by the other who are waiting, and the process can continue and the whole situation comes out of the deadlock. If aborting one process does not make any change in the deadlock situation, then select another process, abort it. So any given time, select one process, abort it, and verify whether deadlock situation is still existing or have we come out of it. If we have come out of it, then we can stop aborting any other processes. If deadlock situation is still continuing, then select one more process, abort it. So that way what could happen is somewhere we get into the cycle, and if one of that process in that cycle gets aborted, then cycle is no more existing, this wait cycle is no more existing, and one condition for the deadlock is no more existing, and hence there should not be any more deadlock. So that's the idea. Now the issue is when we abort a process, what happens with the resources. So the resources are automatically released, but other way, is it really necessary to terminate a process or abort a process? This whole problem of deadlock is arising because four conditions are to be met. The one condition was the cycle, wait cycle, and in the previous thing, that is by terminating a process we are trying to break that cycle, that way we could do it. And there was another condition for deadlock to occur was no preemption of the resources. So if we can avoid that one, so if no preemption can be removed temporarily whenever we find a deadlock situation, then we can come out of deadlock. So we have a deadlock. Deadlock means there is a closed wait cycle is there, and all the resources that are attached to the various processes are under no preemption status, and hence this deadlock condition continues. So to break the deadlock, one option would be to make some resources as preemption. So one resource is already attached to a process and another process is waiting for it, and then once we know that the whole thing is in deadlock, therefore the resource what any process is holding has no meaning, because it is waiting for some other thing, and till it gets some other thing it cannot continue. So the current resource what it is holding cannot be used. So once we know that it cannot be used, then why not release it? So some resources, if you announce temporarily that situation that preemption is possible, then what happens is that particular resource gets released, in the next cycle, next timestamp, and once it is released, the one which is waiting for that particular resource acquires it, and it may happen that that was the only thing it was waiting for, and it continues its execution, and that way we may come out of deadlock situation. So that is one way. Other way is if that after preempting a resource still deadlock continues, then look for another process, and any resource it is holding, then preempt it, release it forcibly, and then that way we can try. So what are the effects of that? How to do that is, first thing is identify the victim, which one should be a victim. Yeah, we as per the convenience, the earlier the processes were allowed to request for the resources, and if the resources were available they were given, and that way the various processes have acquired various resources, and now asking for some other resources that are available or attached to some other process, and hence we are unable to allow that resource to be given to this particular process, and that's how deadlock has come. As we have seen that the deadlock can be avoided or can be recovered by preempting the resource. Now the question is which process should be taken up. So one of the processes that is in deadlock has to be selected. So that process will be, one process will be selected, and the resource will be released forcibly by making it preemptive. So the issue is how to select. Yeah, we have to decide on that, and once selected resource is forcibly released, then that particular process is no more having hold of that particular resource, and it may so happen that it has already used some part of that resource for something, and if we release it, then the next time when we get that resource back, it is not possible to start where we had left, because we don't know where we had left, how much of that resource was used earlier, we don't know. Therefore, before releasing any resource, just look back from when this resource was being used. So roll back to that particular state and say that next time when this process gets a chance to acquire the released resources, then it should start at this location again, so that everything begins from the first line of that particular resource usage and all that. So we have to be very careful about this rollback situation. So the next issue is about the starvation. It may so happen that every time the same process may become a victim, or every time the same resource may become a victim. In that case, what could happen is a particular process will never get a chance to execute, will never get all the resources it wanted, and hence there is possibility of starvation. So that's what the deadlock recovery is all about. So we have seen in the previous session that we allow deadlock to happen and then go for recovery, instead of thinking in advance that next instant there may be deadlock, next instant there may be deadlock. So instead of worrying like that, let's be comfortable and then look at when there is deadlock, because deadlock occurrence has become a very rare now because of large number of resources available, and because of this the occurrence of deadlock has come to very small size, so very rarely it happens. Therefore, instead of worrying every time what if deadlock happens and all that, you can just relax and let the deadlock occur. Happens once in a blue moon, so whenever it happens, okay, let's take care, let's detect that there is deadlock. So only thing we need to do is regularly keep checking, is the system working or is it gone into deadlock. If it has gone into deadlock, then apply this deadlock recovery technique and solve the problem. So that's it for deadlock detection and recovery. One more way of solving deadlock is purely neglect it, ignore it. As we just discussed, the occurrence of deadlock has become very rare. Therefore, don't have to waste our resources, and whenever deadlock occurs, it occurs only because of some negligence of the user or something, and because of this, whatever gets stopped usually is the user's activity, not the kernel's activities, and hence the user process may get disturbed due to the deadlocks and all that. And in that case, we can just neglect it. That is most commonly used solution to deadlock situations in any operating systems like Windows and other things. Because first thing is occurrence of deadlock has become very rare, and second thing is when it happens only the user activities get disturbed, and we can ask the user to handle this situation, so we can restart the program. When it gets into deadlock means our system hangs, so we can just forcibly restart the system and then look into the code what we were working, and then debug it and try to find what went wrong, why it went into deadlock situation and all, try to debug and then fix it and run again. So that could be the easiest solution. So let the user handle the situation, let the operating system be relieved of this. So in the beginning we thought of prevention, then we thought of avoiding, then we thought of let it happen, then let us recover it, and finally we are saying then it is user's process is going to be disturbed, so you can rerun that user process again with minimum disturbance to the overall system. Anyway, let's not give much burden to the operating system to take care about the deadlock and all that, so we can just ignore the deadlock situation, and when the user finds that the system is taking too long to respond, or if it is not responding, then the user will understand something is wrong, so he will automatically restart the system and then verify and then rerun it. So that's all about deadlocks and their 4 solutions. 1, deadlock prevention. So make sure that at least one of the 4 conditions is not met, or deadlock avoidance. So while permitting the resources to the processes, just verify if I allow this resource or if I allocate this resource to this particular process, will the situation lead to a deadlock? Will it be a safe or not safe? If you confirm that it is going to be a safe state, only then resources are allocated, otherwise not. Third one is even neglect that, let the deadlock occur, because it's a very rare event. So whenever deadlock occurs, so we use some recover technique, recover it. The 4th one is best solution, don't bother at all about it, let the user take care. So no headache as far as the operating system is concerned. So if we are developing an operating system, let us not bother about what to do with the deadlock, because today's situation deadlock condition is very rare, so sometime it happens, then let the user take care of it. So that's about the deadlocks, its solutions, and so on. So that's where we have come to the end of the 3rd module. Have any queries, please reach me the following sites. Can mail me, can look at my other YouTube videos, or you can contact me through the LinkedIn and all that. So that's it for now.